Okay, in this video I want to show you how to find a critical value using your calculator, and also show you how to do it finding a table. A critical value is in essence the number of standard errors that our confidence intervals going to the left and to the right. And so first of all, in regards to proportions, you will recall that on our little formula sheet, we can get our formula for our confidence interval roughly, and that is going to be our p hat is our estimate, and plus or minus our critical value is z star, then the square root of p hat times 1 minus p hat over n. And so let's say if we're asked to find, let's say a 95% confidence interval. I think most of y'all by now know that this is going to be roughly 1.96, but our calculator is going to give us a more exact value for our z star. So our confidence level is what determines that critical value. Now, the logic sort of happening here is this, is that with a 95% confidence interval, in essence, 95% of our curve is going to be taken up by the interval. When you get beyond 95% of the values, then you're outside of the interval. So we call this limit here actually a critical value, and we will call this a z star. So if we take the standard normal curve, mean of 0, standard deviation of 1, it is a curve of standardized values. It is in essence a curve of z-scores. It's all these points in here are little z-scores. And so what z-score, or over here, be minus that, being symmetrical here, what z-score is going to put us outside of the interval? Well, of course, once again, on your table, what you could do is you could look and you could get this value. If you look on table B, our critical value table, and you go down to the bottom, 95% confidence, it's going to be about 1.96. But by using your calculator, first of all, you're going to get a more exact value there, but also you'll be able to get critical values for any confidence level, not just the ones that are listed here. So if it was like a 90, like a 97%, or even like a 96.25% confidence interval, you'll be able to do that. All right, so there's a couple of ways of doing this. With the older versions of the 83 or 84, what we're going to do is we're going to use inverse norm to tell us these z-scores. Inverse norm on the older ones especially always works with the left area. So the area, we'll have to find the area to the left of this. If we have 95% of the curve is in the middle, that means 5% is outside of these values. Well, and they're the same area, so this is 2.5%, and this is 2.5%. So if I want to find this z-star critical value there for 95%, the area that's all the way to the left of it is 97.5%, just adding up those two things. So that is, in essence, its percentile. And so what I'm going to do is I'm going to use the inverse norm function, and I'm going to work with the left area. The left area of 0.975. You have to enter it in its decimal form. Mean of 0, standard deviation of 1. The standard normal curve, the curve of standardized values, the curve of z-scores. And so let's see what that is. And so we go to our calculator. We'll call inverse norm is right here in the distribution menu above the stats button. So I go second distribution, and I go down to inverse norm. And so I'm entering 0.975 for the left area, mean of 0, standard deviation of 1. The older versions, the 83, 84, may not have this this screen, and they're not going to give you a choice for left, center, or right. So it'll just pop this up here. And so you would just enter in these three numbers, 0.975, comma 0, comma 1, the comma being above the 7 button, but we hit enter. And so it gives us a more exact value, 1.95. So 1.959963986. So if you want to be really accurate with your confidence interval and with your margin of error, so you could use this value in your calculator and be more accurate. So, or the other thing you could do, if you have the newer version of the 84 like I do, you can use the center area. So the inverse norm of 0.95. Do the center area of 95%, mean of 0, standard deviation of 1. And so when we do that, so I go second distribution, inverse norm, and so I'll do 0.95 because that is the center area. Now it's just going to take that middle area there, and it'll give me both of those values it gives me that. So the critical value, use the positive one. I mean, it's going to be plus or minus in the formula anyway. So there it is. So that is how you can find that. For 99%, I'll just hit second entry. So for a 99% interval, boom, you just do that. And so there it is there. So anyway, now, so that's for proportions. Now, in regards to means, you recall, so this is for means. So the formula for a confidence interval for means is our estimate is x bar plus or minus our critical value of t star and then s over the square root of n. Now we're working with a t distribution, not a normal distribution. It's sort of normal-ish. And whenever you work with a t distribution, we have to state the degrees of freedom because it tells us which t distribution we're working with. It's always the sample size minus 1. So let's pretend that our sample size is, let's say that it is 40. Okay? And so therefore our degrees of freedom is equal to 39, let's say. Okay? And so we're asked to make, let's go with a 99% level of confidence. 99% confidence level. So it's asking us to make a 99% confidence interval for some mean. So to find the z-star critical value, so on the table, what you would do is you would say, okay, here's on the same table B, we would go down to 39 degrees of freedom, which is not there, so you use the closest one to it, which is 40. I mean, when you look at these numbers, they're going to be really close to each other anyway, but you go to 40 and then you go to 99%. So 99% to here, so it'll be about 2.704. Now your calculator is going to give you a more exact value, and so we'll use that. And so we're going to use a function called inverse t. And we would realize now a t distribution looks similar to a normal curve. It has higher tails and a shorter little peak to it. Okay, so this is a t distribution, degrees of freedom equal to 39. It's going to be pretty darn close to normal. But when we're making a 99% confidence interval, it means 99% of our curve is within the interval. So that means 1%'s got to be on the outside. So 1% is going to be on the outside. So that means, and there's two parts of it on the outside, and they're the same area. So this would be 0.5 of 1%. And this would be 0.5 of 1%. So therefore, our curve adds up to 100%. So we want this value. So we need the percent that is to the left. We don't have a center option with inverse t. So we are going to take inverse t of, in our left area is going to be 0.995. I have to put it in decimal form. That'd be 0.99 plus 0.005. That's half of 1%. And then you just have to put the degrees of freedom, which would be 39. And it'll tell you your t-star critical value. And so here we go. And so inverse t is on the distribution menu. So inverse t, there it is. And so our area, meaning left area, is going to be 0.995, and our degrees of freedom is 39. And it's going to give us a more exact value for our t-star. So our t-star, in fact, is going to equal to 2.707913179. That is certainly a large number of significant digits. But that is finding t-star and z-star critical values with your calculator. Many calculators don't have this inverse t, or some of them don't, some of the older versions, and that's okay. I mean, in reality, you can look on the table, and it'll give you what you need. Okay, thank you.